Hello, everybody. So here we are. We are in section 5.4, trig functions of real numbers and periodic functions. So now we are going to be talking a little bit more about the unit circle. This section primarily deals with the unit circle. So as we go forward, make sure you have that handy because the topics that we're going to talk about in here are going to relate to that. We have four things that we're actually going to look at here. So we're going to use the unit circle, and then we're going to look at the domain and range of your cosine and your sine functions, and then talk about even and odd. Now, we talked about even and odd back in the first semester when we looked at actual functions and stuff, but this time around, we're going to focus it on sine and cosine. And then we're going to talk about periodic properties. So here we go. The unit circle. So we have our unit circle, and the reason it's called a unit circle because it has a radius of 1. Your center is going to be at the origin, and you use basically your Pythagorean theorem to be able to figure out all parts of the actual pieces of the circle and everything. So what we need to remember is that the length of the intercepted arc is going to be this t value. So up to this point, we've talked about theta. So now what we're going to be looking at is we're going to look at things in terms of t. The reason that we're looking at this is because later on, when we talk about parametric equations and things, parametric equations are in terms of t instead of theta. So when we're looking at this, the length of your intercepted arc here is still going to be s, but instead of theta, we're going to use the letter t instead. Also, the radian measure of your central angle, which we just talked about, is going to be your t. And then in the unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. So remember, when we talked about that formula that we used way back when, that your s is equal to r theta. So now your S is going to be equal to RT, which means in a unit circle. So this is for a unit circle only. Your S is going to be equal to your T. The reason being is because we already know in a unit circle, the radius will always be 1. So your S will be equal to the T. So that's just another one of the things that we're actually going to be looking at here as well. Okay. Oh, actually, I just talked about that. I went a little fast ahead of myself, didn't I? So, and I know this looks like a hot mess here. So let's see if we can make some sense out of it. So this is your unit circle. And what happens is this is going to be what's called a parametric plane. So we have the Cartesian plane where we plot your x and y coordinates and things like that. But in a parametric plane, we look at angles and radius. So if you take a look here, now it's kind of hard to see, but if you take a look here, 1, 2, 3, 4, 5, these are the lengths of your radiuses here, or radii, I should say. And then this point right here, so if I just take, for instance, this point right here, that is going to be your point based off of your t value there. So that's going to be your xy coordinate point there. And then, but it's based off of what your actual radius will look like. And so really the only thing that kind of changes is in this is going to be these points here, because they're going to be kind of a, let's say like a multiple, I guess, in a way, a multiple of what you're looking at here, because obviously this is going to change. But if you'll notice that your angles, when we're focusing on those will always stay the same. Okay. But this will be something that we'll talk about later on when we actually go through and start plotting these points and taking a look at this and everything else. So let's talk about definitions of the trig function. All right. So I told you way back when we started talking about this, that your x value is cosine and your y value is sine. So remember, xy in this case is going to be cosine sine. So what happens then is when you have a unit circle, your cosine sine is actually the actual value of your xy value. So what this is saying is that your sine of t, whatever you find, will be your y. And the cosine of t will be that. So it's the same thing that we talked about in 5.3, except this way we're only focusing on the unit circle and that's it. So everything that we're looking at will have the radius of 1, will have, all those properties of the unit circle. So we won't have to worry about trying to convert things or use Pythagoras or anything else to actually be able to go through here. So use the figure to find the values of the trig functions at t. So if I'm taking a look at this, what I want to do is I want to say, okay, I'm taking a look at this, I'm looking here, whatever, and I want to find all my trig values at t. Well, we have 6 trig values. So we have cosine, we have sine, and we have tangent, and then we have their reciprocals, which is secant, cosecant, and cotangent. So when I'm looking at sine of t, because that's what we're focusing on, my sine of t is in my x position. So my answer would be square root of 3 over 2. My cosine, I'm sorry, I lied. My sine of t is going to be 1/2. And then my tangent of t is sine over cosine. So when I clean this up, I get 1 over the square root of 3, which means that this is the square root of 3 over 3. Okay. A reason I do this is so that when we come down here to cotangent, it's easier to figure out. So we'll go to secant. So I take my cosine, I'm going to flip this. So instead of square root of 3 over 2 becomes 2 over the square root of 3. But remember, you can't have that square root of 3 on the bottom. So it's 2 square roots of 3 over 3. And then my cosecant of t is going to be 2. And then my cotangent of t is just the reciprocal here. And that's going to be the square root of 3. So it's the same thing that we've been talking about. The nice thing is that we've already been working about it. So this section actually should be kind of pretty easy. There's a few things that are kind of new, but the majority of your homework when you get in there will actually be of things that look like this. Okay. So it's not anything new that you haven't been working with so far. It's just in a different format. So point P, X, Y is shown on your unit circle. So they're talking about this point right here. Find the values of the trig functions at t. So take a few moments, pause the video, and go through here and find these 6 trig values. Ready and pause. All right, welcome back. So let's see how you did. If you did everything correctly, so we have cosine of t is 5 over 13, which means secant of t is 13 over 5. We have sine of t is 12 over 13, which means that cosecant of t is 13 over 12. And then we have tangent of t is equal to sine over cosine. So remember, it's just their numerators, which means that cotangent of t is 5 over 12. So hopefully that wasn't too hard for you and it was easy for you to be able to figure out. So same thing that we did. Like I said, it's just in a different wording and different style. Okay. Let's look at a different one. use this is a form of a unit circle. Use the xy coordinates in the figure to find the value of the trigonometric function at the indicated real number t, or state that the expression is undefined. So it's one or the other. So what we're looking at here is sine of 7 pi over 6. So we know that 7 pi over 6 is a little bit more than 1 pi. So we're going to go a little bit more than, so we're going to go right here. So there is our 7 pi over 6. And I want the sine function. And we know that sine is going to be the y value. So that means that my answer is negative 1/2. Okay. Same question. So what I want you to do is pause the video real quick and see if you can answer this on your own. And go. All right. Welcome back. Let's see how you did. So we know that tangent is sine over cosine. So first off, 2 pi over 3. Here's 1 pi over 3, which means that this is 2 pi over 3 right here. We know that tangent is sine over cosine. So our sine is our y's, our cosines are x's. So we have square root of 3 over 2 all over negative 1 over 2. Copy dot flip. Those cancel. That means the tangent of 2 pi over 3 is negative square root of 3. All right. Here's another one. Indicate what this answer would be. Pause the video now. All right. Hopefully you remember that pi over 2 is one of your quadrantal angles. And so therefore it's going to be either here, 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 or here. Hopefully you remember pi over 2 means 90 degrees. So hopefully you looked right here and you know that cosine is the x position. So that means that the answer to this one is going to be 0. All right. And there's your color of the day. Let's talk about domain and range. The domain and range of the sine and cosine functions. The nice thing about sine and cosine functions is that they are together. So basically what that means is that the majority of the properties that are hold for sine will also work for cosine as well. And the only reason is that because they are vertically shifted about 90 degrees. So what that means is they hold like a lot of the same properties. So that means, like, for instance, their domain and range, the domain of the sine function and the cosine function. So they both have the same domain here. That's going to wind up being negative infinity to positive infinity. So basically there's no restrictions in terms of the sine and cosine function. However, because of the unit circle, they do have a range. And so their range will oscillate between negative 1 and 1. So that means if you've got a function that has, let's change a different color here so you can see it a little bit better. If you've got a function that has a domain of all real numbers, so here is your xy coordinate, we have a domain of all real numbers, but we're only going to be able to stay between negative 1 and 1. And you're oscillating. So basically oscillating means you're going back and forth. You've got something that kind of looks like this. So that's kind of what's happening here is you got this function that's going to be going through here, and the max that it can be is 1 and the minimum that it can be is negative 1. So your sine and cosine will always be between those numbers. So basically when you're looking at problems, if I tell you or ask you what is cosine of t when that value is 3 over 2, you will tell me that that value actually does not exist because that 3/2 is outside of the range value. So that's what it's talking about there. Again, so when you actually look at it, in this case, this is what a sine function looks like here. When you have a sine function, if you think about your unit circle, now picture the unit circle in your head. Your sine function has two parts or 2 points on your unit circle. Let me go back to a slide that actually has a circle here. Let's go to this one. If I'm looking at this photo or picture right here, now if I'm looking at my circle, I'm starting here at 0, I'm going up to 1, I'm coming back to 0, I'm going to -1, I'm coming up to 1. These are all my sine values, okay? And so if you look at this in my circle here, I've got 2 points here and here that have the same y value. And so if you take a look at what the slide I was just on, this one here, if I was to lay this out flat and have a look at what does the sine function look like if I was to graph it, this is what you're looking at. And you notice you've got 2 points that are right here that where it crosses. Well, if you think about this, I'm starting here at 0 and I'm coming up to 1. So this is my first quadrant. I'm going from 1 to 0. There's my second quadrant. 0 to 1. There's my third quadrant. And then -1 to 0 again. This is my fourth quadrant. So you remember that sine is positive in quadrant 1 and quadrant 2. Well, if you take a look at this graph, this shows you that that's actually a true statement. That since I'm in above the x-axis up here and I'm taking a look at this, and I just picked some random point, I'm just showing you that it holds true that in quadrant 1 and in quadrant 2, my sine values are the same. And if you go back and look at that picture that we were just looking at here, that if I'm in the first quadrant here and in the second quadrant here, my y values are the same. So that means the same thing will hold true when we start talking about the cosine, except it won't be 1 and 2, it's going to be 1 and 4. And so that's things that you have to take a look at when you actually begin graphing these things. Well, what are some properties that we can actually look at? Okay, so keeping that in mind, let's talk about even and odd functions. All right. Even and odd. So remember when we talked about even and odd back in the first semester, if it's even and you change that x value to a negative sign, you get the same x value back. So nothing happens to it. It is what it is. Well, trig properties holds that same function. If you take an x value, plug it in, and you get the same thing back, you get an even function. If you take a negative value, plug it in, and you get the negative value back, you have an odd function. And so if you take a look here, you have 2 even functions and 4 odd functions, and this will always hold true. So this is just something that you need to keep in the memory and keep into play, because especially when we get to proving things or whatever else, they're going to throw a negative sign in here to throw you off. Well, that's just when you apply your even and odd properties to that. So you just need to remember that your cosine is going to be even, which means if cosine is even, then your secant also has to be even because it's reciprocal. And then everything else is going to be odd function because everything else crisscrosses basically. So that's all this is saying here. That when you just remember this, that even is cosine and secant, and odd is the other 4. So let's take a look at some pictures of what some of these graphs actually look like. So if I'm looking here, this is a cosine graph here. And these green figures right here is actually what secant looks like. When you graph secant, the green things here is what secant will actually look like when you actually graph it. You ignore the red one completely. So this red piece here is actually cosine, and then the green is going to be secant. Here is sine here. And so if you take a look at sine, this is one of the reasons why it's odd, because if I took sine and mirrored it across the x-axis, well, remember when you have an odd function, if you take it and you flip it upside down, you get the same thing back. And so if you take a look at this here, if this is my sine function, that means that these u's right here, that's the cosecant function. And so if I took this and flipped this upside down, I get this one right here, which means that they're both the same graph, which is why they're odd. This is what your tangent graph looks like. Again, pay attention to the odd functions here. So tangent is in blue, cotangent is in red. I lied to you. Tangent is in red, cotangent is in blue. And so if I took this one and I flipped it upside down, I get the same thing back. And that's why they're reciprocals. Okay. So let's apply these odd and even functions to this. So find the exact value of each trig function at cosine of negative 60 degrees. So if I'm taking a look at this, I know that cosine is an even function. So since it's an even function, I'm going to come over here and say, okay, well, instead of saying cosine of negative 60, what is cosine of 60? Which is this right here. So that means if I look at that, my cosine of 60 is 1/2. Okay. I know that tangent is an odd function. And since tangent is an odd function, when I take a look at that, when I take a look at that, I bring the negative sign out in the front, which means that tangent is going to be square root of 3 over 3. Okay. So when you do these problems or whatever, just remember your odds and evens, and that way it makes it just a little bit easier for you to actually be able to go through and actually do these problems. Okay. So use a unit circle to find the value of tangent of 4 pi over 3. And then find the value of tangent of negative 4 pi over 3. So 4 pi over 3 is going to be right here. Because remember, it's, no, it's not right there, is it? Ooh, I fibbed. Sorry about that. 4 pi over 3 is actually right here. So we take our unit circle, find 4 pi over 3. And so we know that tangent is sine over cosine. So I have my sine over my cosine. So that's negative square root of 3 over 2 times negative 2 over 1. So that gives me square root of 3. So that means my tangent of 4 pi over 3 is the square root of 3. Which means if I apply that functionality and I apply the odd function to this, I come over here and say, well, if that's the case, I have negative tangent of 4 pi over 3, which means my answer is negative square roots of 3. So this is what it is, and then this is when when 4 pi over 3 is negative. That is what that answer is there. So just apply your even and odd properties to it and then flip the sign because it is an odd function. Okay, so moving on to periodic functions. So in nature, in life, or whatever else, things have patterns, and these patterns tend to keep repeating over and over and over again. For instance, like if you think about it, the ocean level of a beach, it varies from high tide to low tide, and then back again, approximately about every 12 hours. So you can actually take a measurement of high tide and low tide and actually put it in the form of a trig equation that we'll talk about in the next section. And so what happens is that when you're looking at this, you can actually talk about how, well, if I know every 12 hours my high tide will be the same every 12 hours, that means that if I have a function and I add the 12 hours to that, they're going to wind up being the same thing. So when we're looking at these periodic functions, it's in that same format. So a function is periodic if there exists a positive number such that this winds up being a true statement. So basically, there's going to be in one specific full rotation. This is what it's saying. In one specific full rotation, you will have two y values that will be the same when your x values are different. And again, I'm going to go back to this picture here. So if I'm taking a look at this and I want to kind of, I want to graph this, I want to take a look at this. This shows you right here at this point here and this point here that on this one complete rotation of a unit circle, I have two y values that are the same when I have two different x values. And that's what a periodic function does. It goes through that. It's not the same as a parabola, because a parabola, all it does is it comes down, turns, and comes back up forever. In a period, this keeps going on and on. This format like this will end never, because again, you have a domain that's, from negative infinity to positive infinity. So if you're taking a look at this right here, this is saying, because I have this domain that goes on forever and there's no restrictions or whatever else, there will be these 2 points at equal distance, apart from each other, that will be of the same y value. So this is what you look at, and this is how you figure it out. If I take my sine and I look at it and I take the first revolution and I add another full revolution, I get that same value back. And so sine of some random value plus 2 pi will generate the same thing as sine of t, which, that makes sense, because I have this circle. If I go to 30 degrees and I make one full revolution from that revolution, not revelation, if I make one full revolution from 30 degrees, then I wind up back at 30 degrees because I've gone 360. So at 390 degrees is the same thing as 30 degrees. And so if you kind of think about this, if I keep doing that over and over and over again, we have these same things. They're called coterminals that we talked about at the beginning of the semester, where you have the same stopping point. But when you put it on a graph, they have the same y value. So even though this piece right here is going to be a different value than your original, they will hold the same y values, because once you go a full revolution, it starts back over again. So find the exact value of the trig function. So if I'm taking a look at this, the first thing we need to do is we need to get this number. So this goes way back to when we did 5.1. We need to force this number between 0 and 360 so it's something that we can work with. So I go through here and I take my 405 and I subtracted 360 from it to force a number that's going to be between 0 and 360. Well, that'll be 45. And now that I've done that, I set that equal, and I look at for the actual answer. So what is cosine of 45 degrees? That is square root of 2 over 2, which means because 45 degrees is square root of 2 over 2, 405 is also going to be square root of 2, because again, if you think about this, if you've got, I pressed the wrong button. If you've got your circle that's right here, if I start here, and then if I keep going around again, I've gone 2 revolutions now and I stop at the same spot. So the blue is 45 and the red is 405. They're the same answer because I've gone one full circle. I haven't done anything unusual. I've just gone an extra circle around and I wind up in the same exact spot. Same thing with 7 pi over 3. So sine of 7 pi over 3, again, we need to force this back down between, in this case, because it's a pi, between 0 and 2 pi. So you come over here and say, okay, well, 7 pi over 3, so I need to look at 2 pi, which 2 pi is the same thing as 6 pi over 3. You subtract the 2 and you wind up with sine of pi over 3. Sine of pi over 3 is square root of 3 over 2, which means sine of 7 pi over 3, because you've gone one full revolution, is square root of 3 over 2. Okay. In form of tangent, the difference between sine and cosine and tangent and cotangent is tangent is only on a revolution of pi. So, the repetitive behavior of sine and cosine and tangent functions. So, when I'm looking at sine, cosine, and tangent, they're going to repeat, and they're going to repeat over and over and over on their specific periods. And so, if you're looking at how this is written, notice that the 2 pi here for your sine and cosine is what that one period would look like. And then in tangent, that's the same thing that would happen there because they just repeat over and over and over again. So they just keep going until you tell it that you need it to stop. If you don't tell it that you need it to stop, it will just keep going. So that's why you'll see, especially when we start solving a lot of problems and everything, you'll see the problems restrict you, and they'll restrict you between, a starting point and an end point, because these tend to keep going on and on and on forever. Okay. So, number of hours of daylight. So, number of daylight hours on any given year can be modeled by this problem here. So, this is legitimately just a plug and chug problem. And so, all you're going to do is you're going to take this problem and you're going to plug in whatever number it asks you to, to be able to get the answer that it wants. So, on March, the 79th day of the year, is the spring equinox. Find the number of daylight hours in the city on this day. So what you're going to do is you're going to come over here and you're going to say, all right, you're going to plug in your formula. Now, here's the easiest way to do that. You plug in your formula here, and you're going to plug that into your Y1, and then you're going to go to your table and make sure it's set to ask, because that's the most important. So you'll generate this problem. And then you're going to answer each one of the questions. So now we go back to this here. If I'm looking at 79, I'm going to come over here and I'm going to type in 79 and I get 12. So we'll have 12 hours of daylight on the 79th day. On the 171st day, I type that one in and I get roughly 20.1 hours. And then on the 354th day of the year, I get roughly 3.9 hours. So literally, this is just taking the problem and plugging in numbers to get your answer for that. Okay. So with this being said, I hope that this wasn't too bad for you. So go ahead and get into Blackboard and start working on 5.4. Remember, use your unit circle, because that's where a lot of these problems are going to come off of, is that unit circle. If you have questions, pop into Google Meets and let's have a chit chat. Otherwise, I will see you when I see you. Okay. I hope you have a great day, and I will see you when I see you. TTFN. Ta-ta for now.